All right, we are starting section 2.1, but we're going to need to review a little bit of these identities that I've shown you before. They were actually in section 1.3. So they're, if you want to get them out of your textbook, they're on section 1.3. They're also on page 222 in your textbook. So if you look at page 222, which is section 2.1, you could get the identities as well. Now, some of these you'll remember because the reciprocal ones are pretty easy to know. We know that sine and cosecant are reciprocals. We know cosine and secant are reciprocals. Tan and cotan are reciprocals. So those are ones that are pretty easy to remember. These are important ones right here, the quotient, especially this first one. Because we have sines and cosines all the time. And when you have a sine and you divide it by a cosine, you will get a tangent. So that's a big one, and then the reciprocal of that would be cosine over sine would be our cotangent. And Pythagorean ones also come in handy, especially this first one right here. Sine squared plus cosine squared equals 1. Now, when you're working on your page in class, because we'll have time at the end of the period, I'll just put these up here on the board so you can see them. But when you get home and work on it at home, you can look at page 222 is where they'll be. And they're also in your notes, so I think you wrote them down once. Here's where we're going to start though. Secant is negative radical 3 over 2. Tangent is greater than 0, meaning it's positive. That's the clue that they're giving us. It's a positive tangent. And they want us to find the other trig function. Now they did say use identities. Now we're going to look at it, analyze it, and see if identities would work better, or if maybe drawing a triangle would work better. First thing we want to do though is we want to find the 5 trig functions that we don't have. We need to find sine, cosine, tangent. We need to find cosecant, and we also need cotangent. I didn't put secant because they gave us the secant in the problem. So all we need are these other 5 right here. One of them we could find really fast. Which one do I already know? Flip the secant around, you'll have cosine, right? So if you flip around the negative 3 over 2, you're going to get negative 2/3. So your cosine there is just negative 2/3. Now we need to find sine, cosecant, tangent, cotangent. Let's take a look at what we've got. We've got a positive or negative cosine, which if you remember represents our x value on our unit circle. The sine represents our y value. Remember on our chart we put a y above sine, we put an x above cosine. Above tangent, do you remember what we put above tangent? Y over x. So tangent really represents y over x. And we notice that the tangent's a positive. So how can I take a y divided by an x and get a positive number? Either they both have to be positives, or they both have to be negatives, and you would still get a positive tangent. So if you think about that, and you draw a little x and y axis, what 2 quadrants does it have to be where the x and the y are either both positives or they're both negatives? Quadrant 1 would be both positives. Quadrant 3 would be both negatives. So you've got to either be up in this quadrant with your triangle, so that's what would give me a positive tangent, that's right here, or I got to be in quadrant 3, and that would also give me a positive tangent. What quadrant do you think it is based on the fact that the cosine is negative? Got to be quadrant 3. The cosine's negative, that means the sine's going to be negative. So I could already put a little negative sign here, which means I know cosecant's going to be negative because it's just a reciprocal. Tangent and cotangent are going to both be positive. So I just want to make sure I get my signs correct, the positive and negative signs. Now if I have a secant, or I could even say cosine here, this represents my adjacent side as a 2. So if I'm going to quadrant 3, this is a 2 on top, and I'm actually going to be a negative 2 because you're going left. This 3 represents a hypotenuse. So there's my hypotenuse of 3. how would I find my opposite side over here? It's Pythagorean theorem, right? A squared, b squared, c squared. It's going to be a radical 5, positive or negative? Negative, it's going down, right? So we're going down radical 5, it's going to be a negative radical 5. Could we now find our other trig function? What would my sine be? Negative radical 5 over 3. What would my cosecant then be? When I just flip that one over, I'm going to get a 3 over a radical 5, right? It's going to be negative. I need to multiply by the radical 5. So negative 3 radical 5 over 5 would be my cosecant. What about tangents? What's tangent stand for in trig here? TOA, right? TOA, opposite over adjacent. So here's my angle up here. What's my opposite to that angle? Negative radical 5. What's my adjacent? Negative 2. Negative over negative is a positive. So you got radical 5 over 2 positive. We knew it was going to be positive because they told us that in the problem, right? And then the cotangent's going to be 2 over radical 5. So we would need to fix that. By multiplying by 2, you're going to end up with 2, or multiply by radical 5 on top and bottom. You'll end up with 2 radical 5 over 5. So that's how you could find the other 5 trig functions if they gave you these two pieces. Now, you could have used identity a little more than we did. We used our reciprocal identity. We didn't really use an identity to go from cosine to sine, though. And we could have. We could have used the sine squared plus cosine squared equals 1. We could have taken this negative 2/3 and plugged that into the cosine and then solved for sine. And that would have worked. That would be a lot of equation stuff that we'd have to figure out. And so the shortest method would be to make sure you have the triangle in the right quadrant. And then draw your triangle, find your other trig functions that way. Always knowing that when they give you a trig function here, that's 2 sides of a triangle. This, in this case, is a hypotenuse over adjacent. And when we flip it around, it was adjacent over hypotenuse. Second one. Hopefully you can remember some of your Algebra 1 stuff. Because there's a lot of factoring in this section. Like the next one at the top here is a GCF. Remember what a GCF is? Greatest common factor means you're going to take out a sine of x from both terms. So we're going to divide them both by the sine of x. We're going to take this and bring it to the outside of my parentheses. What's going to be left over on the inside? The sines would cancel out. I'd have cosine squared. And then these would cancel out. What would I have? Just 1. So cosine squared minus 1. It says simplified, so this could be done if there's nowhere else we could go. If there's nothing else that we could do to make it smaller, you could be done. But we need to check. Remember the one I just wrote on the board a second ago? Cosine, or sine squared plus cosine squared equals 1? What if I subtracted cosine squared on both sides? Sine squared equals 1 minus cosine squared. Does this look like this? Close. What's different about it? The negative cosine here is a positive cosine over here. The negative 1 here is a positive 1 here. So both signs are different. How could I change this so that the both signs might be different? Well, let me do this. Let me just say, what if I took out a negative sign from both? What if I divided these both by negative sign? If I divided this by negative sign, I would get a negative cosine of x. And what's a negative divided by a negative over here? Positive 1. Now are these two the same? Now we can take this sine squared and we can put it in for the cosine squared, negative cosine squared plus 1. So I'll get negative sine x, put in a sine squared x. And what would I get if I multiplied those two together? Sine times sine squared would be sine cubed. Yeah, sine cubed. So you'd actually have negative sine cubed x would be your answer to that. This is algebra, yeah. So you're going to have a lot of algebra stuff on this one. There's this, like these next two are factoring ones. Because it says simplify, so I need to try to make it as small as possible. If I would have just left it like this, or without the negatives, it just wouldn't be as small as I could get it. This is like reducing it all the way down as far as you can.
No, that's your final answer.
This would be the final
What
answer.
happened to the cosine?
We took this out right here. We took this out and we put that in its place. Because of this identity tells us that right there. That identity tells us that we can substitute one for the other. Now look at this letter A right here. If I was to write x squared minus 9 next to that, it said factor it. Remember difference of squares where you have, this is a perfect square, x times x. This is 3 times 3. Do you remember the two parentheses? X plus 3, x minus 3. Well, what do you think these two parentheses are going to be? Exactly. You're not changing anything. You're just, instead of an x, you're putting a secant of x. Secant x plus 1, secant x minus 1. It's the same exact step. You're just, instead of having one variable, your variable is a trig function. Your variable would be the secant of x instead of just x. And it's the same thing in letter B. Take out the tangents and write it like this. 4x squared plus x minus 3. I took out all the tangents. I like x better than theta for algebra, so I would use x there. And I would see if I could factor this down. You remember your algebra? I know in my students I taught them the star method. It's the same as the x, except it's a little easier because it's got, you can see if you can reduce your fractions and you get your two parentheses right away. You multiply 4 times negative 3, negative 12, that goes on top. You have a positive 1 here, that goes on the bottom. Your middle term always goes down at the bottom. Your 4x would be up here, 4x and 4x. So it's whatever's in front of the squared term goes on the top of the star. And then your bottom numbers are whatever you multiply to get negative 12, that would add to give you a positive 1. 4 and negative 3. They got to be different signs because it's a negative 12. So 4 and negative 3. These are my two parentheses. Except you got to see if you can reduce any of them. 4/3 you can't reduce, but what about 4 over 4? Yeah, you can make that a 1 over 1. So really my two parentheses would be x plus 1 is my first one. You got an x and a 1. They're both positive. You got 4x minus 3 is my second parentheses. So that's what I call using a star to factor this one down. So what do you think my two parentheses for this one are going to be? The exact same thing. Instead of x plus 1, right here, you're going to get tangent of theta plus 1. Instead of 4x minus 3, what am I going to put? 4 tan theta minus 3. This right here is like our x. This tangent of theta is like our x. So you're just factoring like normal. But instead of an x, you're just going to put tangent of x or tangent of theta or whatever they use, whatever letter they use. So it's a lot of algebra 1 stuff where we're just factoring that. And a lot of fraction stuff. If we can know how to add fractions or multiply fractions on the next couple, you're going to see that you're going to need to just review your fraction stuff. All right, moving on. We're good? All right, this one is another factoring one, except it's got different trig functions. And you can't factor it if it's got different trig functions. So somehow we got to take one of them out and make it all the same trig function. Look at my identity. You see an identity on here that has a cosecant and a cotangent where we could like replace one of them. Any one of them have a cosecant and cotangent. Where? Which one? The very, very, very last one. Look at the very bottom one. It has 1 plus cotangent squared equals cosecant squared. That's the one that you could have a cosecant and a cotangent both in there. So let's go back to here. And cosecant squared is the same as 1 plus cotangent squared. So I'm going to take this out and I'm going to put this in its place. And then minus cotangent and then minus 3. I'm going to bring everything else down. So now I have cotangent. I don't have anything but cotangent. I do need to combine my like terms, the numbers, the 1 and the negative 3. So I'm going to still have cotangent squared. I'm going to still have a negative cotangent. But what is 1 minus 3 over here? That's my negative 2. If I use my little star like I did last time, I would multiply the first number, which is a 1, times the last number, which is negative 2, so it would be a negative 2 on top. My middle number would be negative 1. Cotangent x is what's in front of the squared. And what would be the two numbers that would multiply to give me negative 2 that would add up to negative 1? Multiply to give me negative 2. Got to be different signs. Add to give me negative 1. What is it? Negative 2 times 1. So your first parenthesis is right there. Cotangent x minus 2. Cotangent x minus 2. Your second one is right there. Cotangent of x plus 1. There's your two parentheses. That's factored. That's all it's asking to do is factor. We can't solve it unless we can factor it, so we got to break it down first. So we're going to need to be solving these in the next few sections. Okay, there's just 2 left. This one right here I'm going to bring down as a sine over 1. Everybody okay with that? I can just put a 1 under it, right? It makes it a fraction. I'm going to take this cotangent and bring it down as cosine over sine. I'll put in the x's later. So do you notice that right here? Cotangent equals cosine over sine. So what I did is I took out the cotangent and I put in cosine over sine. And then times, and I'm going to bring this one down as cosine over 1. Should I add or multiply first? Multiply comes before addition and subtraction. I need to multiply these two together first. So I'm going to bring down my sine over 1 plus, now what do I get when I multiply straight across there? Cosine squared over sine, right? So cosine squared is cosine times cosine over sine. Okay, so that's good. But now we need to add them. And how do we add fractions? Common denominator. So how do I make those to have a common denominator? This first one by sine over sine, right? Sine over sine is equal to 1. So you're keeping the value the same. And you're making a common denominator. So you'd have sine squared over sine plus cosine squared over sine. So your common denominator there is a sine. You've got a sine under both fractions. So you could actually bring this over and put a sine. And the top is going to have a sine squared plus a cosine squared. Sine squared plus a cosine squared over the sine. So the directions they simplified, does that seem like it's good enough? So you're saying I could reduce these? No, because this is in parentheses. When you got a plus on the top of a fraction, it's like a parenthesis. Okay, you could keep that together. Is there anything else you think we could do? Okay, do you remember this identity right here? Sine squared plus cosine squared equals how much? 1. Okay, sine squared plus cosine squared is 1. That's right down here. Sine squared plus cosine squared equals 1. Every time it equals 1. So what I need to do then is take this sine squared plus cosine squared out and just put 1 over sine. That's a lot smaller than the sine squared plus cosine squared. And 1 over sine squared, we actually can change that too. What is 1 over sine squared? 1 over sine, What's 1 over sine? Cosecant. So that whole thing simplifies all the way down to cosecant. I know it's a lot of work, but it does work. All the way down to cosecant. All right, moving on. Last one here. It just says add and simplify, so we want to put them together. In order to put them together, you got to have a common denominator. So what can I multiply this first fraction by? Sine over sine. That's equal to 1, and it's keeping the value the same. So I'm going to end up with a sine squared over my denominator, which would be sine times 1 plus cosine. That would be my denominator. Plus, what do I multiply this fraction by to come up with this denominator? 1 plus cosine. So my denominator will be the same. Sine times 1 plus cosine. My top number on this side, I'm going to distribute because they're both cosines. So I'm going to distribute it. So I get cosine times 1 is cosine, plus cosine times cosine is cosine squared. And look at the top. All I did was I distributed this cosine to the both terms. So cosine times 1 is cosine. Cosine times cosine is cosine squared. So that's what we have so far. Now my denominator is sine times 1 plus cosine. I could distribute these. I don't want to. No. It would be like adding x plus x squared. You can't. You got to have x and x or x squared, x squared. Now when I bring all these top ones, all of these over to here, I'm going to first put sine squared. And I'm going to, if it's okay, could I flip these two around? Can I commute them?
Yeah.
I can put cosine squared first, and then I could put cosine. So I kind of keep them in descending order. Okay, so I'm going to do that. Now, does anybody see what I might be able to do next?
Simplify.
Okay, good. Anybody see anything special? Where's the 1? Aha, right here again. That equals 1. So I'm going to take that out. I'm going to put in 1 for that, and then 1 plus cosine. On the bottom, I've got sine times 1 plus cosine. So what do you think? You can cross cancel those. You're going to get 1 over sine again. So what is that going to equal? Cosecant again, yes. So that goes all the way down to cosecant once again. That's just factoring. It's all out, a lot of algebra 1, a lot of fraction stuff. Just putting in tangent or trig functions with it.